It's 6 p.m. on the West Coast right now, so I think we're going to get this thing kicked off and started for today, so that we can get Joseph into his presentation, get Matt back on his vacation. So welcome everyone to the January edition of the Vancouver Power BI and Modern Excel User Group Meetup, Power BI edition. Let me just make sure I'm clicking in the right place here so things are working here. We're just jumping into the welcome and overview right now, and I'm looking forward to getting Joseph on stage to talk about Python integration in Power BI in about 20 minutes or so. All right, and first I'm going to go through and find the mute buttons on things for folks. If you have not muted yourself, if you please could, that would be fantastic. I'd really appreciate it. Otherwise, I'll hunt you down in just a little bit. I sure wish Teams had a feature to actually mute everybody when they joined. That would be awesome. They should learn from Zoom. Anyhow, I'd like to throw out a big thanks to our sponsors. The feature or title sponsor for the Vancouver Power BI user group going forward here is skillwave.training, which is a joint effort between myself and Matt Allington, who we have with us today. So Excel Guru, of course, is my company that goes with this. Monkey Tools is one of our products that we want to let you know about. If you're building business intelligence models with Excel or Power BI, you'll find that there's some use in this tool for you. So big thanks to Skillwave here. And there'll be a couple of announcements coming up in a bit related to that. So the next meetups that we have coming on, for some crazy reason, I decided that I was going to do something on Power Automate next meetup. I'm not 100% sure why, so it should be entertaining. I've got little knowledge in there, but I'm going to share what little knowledge I have and some of the challenges that I actually ran into trying to build a solution without documentation, because that's the way that everything is the most fun. Our next Power BI track is going to be coming up on February 17th. We're going to be welcoming Joel Gagnon, and he's going to be talking about maximizing the impact of Power BI applications by improving the user experience. So this could be a good topic to have as well. We're looking forward to both of those coming up, and the RSVP should be open for both. As I mentioned, Skillwave is our title sponsor now, and we have decided that we're going to actually move all of the meetup recordings for the Vancouver Power BI user group are going to be hosted on Skillwave's YouTube channel in future. Now, we've moved over the one from Cristiano that we had last week. We've actually moved that onto the Skillwave channel. Once we actually upload tonight's recording, it will also be going into the Skillwave channel. So if you're looking for that, you can find it at this short URL right here. That's where you're going to want to subscribe so that you can actually get access to the content from these things after the fact. And of course, like normal, I'm also going to post it in Meetup to let you know where the links are as well. Along with that, I also want to let you know that that's not the only thing that's going to be happening at the Skillwave YouTube channel. A little bit earlier today, I actually released the very first episode of Monkey Shorts. This is a new series of videos that I will be releasing on Skillwave's YouTube channel. They're going to be weekly. They're going to be focused on Excel and Power BI. And in order to give myself a real challenge, I am trying to cover a technical tip in less than 3 minutes. And that's what these things are all about, is bite-sized videos with some things that hopefully you'll find helpful. If you are interested in checking those out, the playlist that you can to get into those, the first one, the introduction of what the series is all about, as well as the first Monkey Short video is available, and you can find it at this link here, which I will dump into the chat once I'm done my presentation here. I also want to let you know, this may not be targeted at you per se, but maybe you've got someone on your team that you just wish had a better handle on actually working with the fundamentals of Excel. If that's the case, I would encourage you to check out a brand new product that we've actually just launched at Skillwave. Our first semester is opening on February 15th. This is generally training that I actually provide to teams, but it is now going to be happening. People can sign up on a one-on-one basis. It comes with video training and coaching to help people learn the core fundamental skills of what they actually need to know to work with Excel and Power Query, not necessarily so that they can be data analyst ninjas, but so that you know when you give them a solution, they're going to know how to understand it, what to do with it, and maybe build some solutions themselves. If you'd like to check out the full details on that, you can find that at the link here as well. These slides have already been uploaded to the Meetup site, so you can always get all those links there. The last thing that I'm going to close off with here, like usual, is if you are interested in speaking at the Power BI user group on either Excel or Power BI or anything that ties into the Power Stack of products that we're actually dealing with here, we would love to have you. Please go and fill out this little survey here, and we'll get in touch with you and get you onto our stage. And that is what I've got for tonight's intro section here. Hey, look at that. I'm actually done within 5 minutes. That never happens. So I'm actually going to close off my my deck right here and stop sharing my screen because nobody really cares about the penguin background I have. And we'll turn it over to Matt. Matt, are you ready for the What's New in Power BI for tonight?
I'm definitely ready. Thanks, Ken. Thanks for the invitation to joining today. Just I'm going to start off with an apology. So I'm currently not at my home base. I'm traveling, and as a result of that, I have a very bad satellite internet connection. In fact, while you were just talking, Ken, not that I wasn't listening to what you were saying, but while you were talking, I just did a quick Google. So the internet that I'm using is from this SkyMaster satellite, which is orbiting the Earth at 36,000 kilometers away from where I am. And as a result of that, I've got 1 megabit upload speed, and there's wait for this, it's about a 900 millisecond ping on my satellite. So there is definitely some delay, and because I've got poor bandwidth, as a result of that, there's definitely going to be some delay in this presentation. So
doesn't have
just
anything to do
wanted
with
to
Tongan
apologise
volcanoes,
in advance. I don't think so. No. So, but anyway. So look, I'm going to talk about what's new in Power BI. There's been no release in January 2022. I'm sure most people are aware that Microsoft, they release every month, but they normally take 1 month per year. So it's either the December release or the January release. And so this year, no release in January. And look, I'm just going to talk about 2 features. Given that the release is effectively a month old already, you may already know about these features, but I certainly find it helpful to sit and listen to someone talk about something that they've seen in Power BI, and hopefully it'll be the same for you. So the 2 things we're going to talk about, first of all, is sparklines. And so what I'm going to try and do is throw up my my Power BI report, and I'll do a quick demo on sparklines, and I'll sort of try and do the talking and try and coordinate the video because of that lag. So the first thing that I want to call out is that sparklines is currently a preview feature. And so when you download the December version of desktop, you need to come into the file menu, options and settings, and switch over to options and find the preview setting features. So it's always here in the same spot, about third from the bottom of the global settings. And you'll see here that there's the sparklines preview feature is here. So you have to turn that on. If you don't turn that on, you won't get to see sparklines at all. So once you've got it turned on and you've shut down desktop and reopened it again, then it's actually pretty tightly integrated into the UI. So I've got this is a table, just standard Power BI table here. I've got a measure, so, and this is AdventureWorks. Sorry, I always use AdventureWorks. So this is the AdventureWorks database. It's got 4-dimension tables, and I've got 2 fact tables loaded. And if we jump back to the report page, I've got a visual here, which is a table, and I've got country, territory, and this total sales measure here. And so if as I jump back to the visualization pane, in order to insert a sparkline, you come over here, literally hover over a measure. This also will work if you're hovering over an implicit measure. So if I was to bring, say, like this order quantity column in, this also works. You just right-click on the measure, and then you'll get this additional option now called Add a Sparkline. So I click Add Sparkline. Now, for this demo, the one I've got here, this is a measure, and as a result of that, there is no summarization choice available here. So because, as you would know, a measure has the summarization embedded inside the formula, and so there is no opportunity for me to choose the summarization at this point in time. So I've got the total sales measure, and I get to choose the axis for the sparklines. Now, the most common sense way to do a sparkline, in my view, is some sort of time pattern. And so I'm going to open the calendar table, and I'm going to find and use this month ID column as my x-axis. Now, in my case, the month ID is a unique ID for each individual month in my calendar. So January 21, February 21, March 21, and so on. not sure if that's a question or someone with a speaker on. So, all right, so I click create, and lo and behold, we get this sparkline that pops up. And notice that once the sparkline appears in the visual, you actually get a new object sitting inside the values well over here on the visual. So you can go in there and rename that if you like, just like you can any measure or column that comes across. And in fact, there's a stack of formatting features now that you've got the sparkline in. So by default, it's a line. I could also switch it up to a column chart. So with this new visualization pane, you switch over to the format visuals. You've got this new sparklines formatting card here, and there are a few features. I'll just try and expand them all. If you've got more than one sparkline, you can select which sparkline you're trying to format from this first drop-down list. You can change it to a column chart, which may or may not make sense. It really depends on the data that you're trying to visualize. And a few other settings down here. Why can't I get to, once I go to a column chart, there's a different set of settings. So I come down back to my line chart. On the line chart, you can start highlighting things using markers. So I really like this concept of turning on the highest and lowest marker. So I really think it enhances the sparkline to be able to see that in Canada, over here, we had the peak. This is actually the value that is given here. So the peak is 161,000, and then the minimum point is over here. So that's just a great way of enhancing the data. Now, Sparklines, it's still in preview mode. So there's a lot of things that will be improved in the coming months, and Microsoft is definitely still investing in this, but they need to get the product out so that people can start using it and give feedback about what's working and what's not working. It is possible to use something other than a date period, and I'll just show you that. So maybe I'll bring order quantity. So in this case, it's an implicit measure. So this is a column of values, and the column of values by default is aggregated as sum. And then if I come and add a sparkline for that column, you'll now notice that I've got this option to use the summarization method. But I could, for example, use, what should I use? Maybe product category. Now, this won't necessarily, I'll use color actually. So this won't really make any sense, but this is still a sparkline. The problem with using color is that you actually can't see what the underlying values are. So I can't implicitly tell that the first one is black or whatever the color is. So I'm guessing Microsoft's trying to not limit the usability of sparklines, but to me, the real value comes when you do some sort of trend, be it a day or a month or something like that. Okay, so that's sparklines. Also happy, I don't know, Ken, if people sort of ask questions, maybe to put them in the chat, feel free to unmute and
yeah, the only comment you've got so far is just a shame for using an implicit measure, but I think you had to show it, right? You're not recommending it, so.
Oh, yeah. Oh, no, definitely do not use an implicit measure. I mean, look, I use implicit measures when I inspect my data, and I'm not planning on using a measure. So they're good sort of quick and dirty tire kickers. But if I was going to build a model, I would definitely write a measure. So they've got their place. Okay, so the second thing that I'm going to talk about, no demo in this case, or if there is, it'll be pretty minor demo. I want to talk about hybrid tables because this is a new feature, and to me, it's an amazing advancement within this overall Power BI toolset. And so you would probably be aware that there are a number of different modes in which Power BI can operate. So the one that was first introduced is called import mode, and import mode is the mode that loads the data from your source, compresses the data into a tabular model and stores it within the report. So that's import mode, and that's absolutely going to give you the best performance. But it's not the only way to use Power BI. And so the second way that you can use it is what's called direct query mode. And so direct query would be if you've got data at a data source, say it's in a SQL Server database, and you're transacting on that SQL Server database throughout the day, and all always need to see the latest data. So what's most important is what happened 1 minute ago. Well, if you were doing that type of analysis, you'd be better off using direct query. The performance is not going to be as good, but the data is always going to be the latest view of the data. And so if timeliness of your data is important, then direct query mode is the best way to use the tool. And then more recently, well, actually it's probably a few years now, but there's this concept called incremental refresh. And incremental refresh allows you to do import mode, but then instead of having to refresh, I don't know, 1 billion rows of data every single day, you can use incremental refresh to load the history and then perhaps just load this week's data or this month's data on a daily basis. So incremental refresh is an extension of the import mode. And there's actually another concept which I haven't got here on this slide, which is called composite models. And a composite model allows you to have both going at once. So you can have some tables that are loaded and stored using import mode, and you can have other tables that are direct query. So that's called a composite model. I'm not sure if that's the official name, but that's effectively what it is. What's new now is this thing called hybrid tables. And what hybrid tables allows you to do is bring all three of these concepts that I've talked about into a single table. Right? So we're not talking one table that's refreshed and loaded and another table that's direct query. This is going to be the same table, but the data is going to be loaded in different ways. And this is an illustration here where you can, and in fact, hybrid tables are an extension of incremental refresh. So the way it works, and I'll show you the configuration of this in a second, but conceptually, you have some historical data, which is refreshed once when you first load the model. Once that's refreshed, you don't refresh it again. That data remains loaded. Secondly, what happens is you set an incremental refresh period. So that might be current trading month. And so say at 5 o'clock every morning, you do an incremental refresh and it doesn't load the historical data. It only loads the new data for the current month. And then this new feature, hybrid tables, now allows you to specify direct query on top of the incremental refresh. So if I refreshed at 5 o'clock this morning, so I've got all of yesterday's sales loaded in import mode, but then I go and run a report, or I navigate to a page, it will send a direct query for the delta. So anything after 5 a.m. this morning will get loaded in real time at the time you refresh the report page. And so you're getting the best of everything brought together. This is a premium only feature. You can use it with premium per user or Power BI embedded or premium. So, but yeah, premium only feature. Just sort of having a look at that from a configuration. In fact, I might just leave it like this. I could show you on Power BI, but given the lag, it's probably easier if I just point to this slide and talk about it here. So what you need to do is you need to switch over to the data view, and in this case, it looks like they're in the model view. So it must work in both of these views. So either select the data view or the model view. And once you're in there, you right-click on the table, and now you'll have this. Well, in fact, incremental refresh has been there for some time, but what's new is this purple box here. So this is the new optional setting for direct queries. Now, when you do incremental refresh, I don't know how much people know about incremental refresh, but there are a couple of rules. You have to set basically a range start date and a range end date, which if we look up here on this image on the left, the way this would work is that you would set your start date and end date to cover the archive data. In fact, I think the dates come in here. So you set the range start date. No, actually, I was right the first time. You say the start date and end date is for the archive data, and then the incremental refresh data is set here. So we would say that we want to incrementally refresh, say 1 day of data or a month of data. And then the third option, this new option, you just click on the little checkbox here, and then any data that's in your table at the source that has been generated since the last refresh. So if I used 5 a.m. this morning, that will get loaded as a direct query. And it all gets appended together. All the partitioning is done automatically by Power BI, and you just get a rapid performance with the benefits of real-time data as well. Okay, so just a couple of things. I really don't have time in this session. It's probably a presentation in its own right to go through the details of how to do this, but just a couple of key things as I was preparing for this. Just a couple of things to remember. Hybrid tables is a subset of incremental refresh, so it's an extension of that. You must have a foldable data source, right? So you can't do this if you're connecting to Excel files. There must be a Power Query foldable data source. And so SQL Server would be probably the most common and useful example of that. You must set parameters in your query. So in my case, I've got a query on the sales table. I might just jump over to this now, even with that little bit of lag. So I'll just show you here. If I right-click and have a look at the query, I'll just give it a moment to refresh on the screen. But you'll see here that I've got 2 parameters in my Power Query editor here, the range start, range end. These are mandatory for incremental refresh, and they must be of the data type date time. It will not work on date format. It must be date time format. And then my sales table actually applies those parameters in the filter. So if I come in here and open up the filter pane, so you can see which filter I've applied, I've actually used the parameter instead of hard coding a value. And so this is standard configuration. This is all documented in the links on how to configure incremental refresh. So so you have to have those parameters in your queries for this to work. If I jump back to my slides, yeah, we talked about the date time, data type, and it only works with premium. So that's it. Hopefully you like those features. If you have a need for hybrid tables, I can imagine it's going to be another one of those game changers where you no longer have to make the compromise between one or the other. You can have the best of both worlds. So I'd be interested to know if anyone uses those.
Hey, Matt, we got one question.
So Ken, any questions?
Yeah, one question just around the performance. Will the hybrid tables have better performance than direct query on its own? I mean, I'm assuming that's the point of it all, right?
I would say definitely so. So look, it always depends. Standard consultant answer is it depends. But you know, the whole idea of, not the whole idea, one of the benefits of import mode is the compression and the performance. It's not saying that you can't query a database and get good performance. You certainly can, but there's trade-offs in the technology, and the tabular model that Power BI sits on top of is designed for reporting purposes and for performance, whereas a transactional database like SQL Server is built for a different purpose. It's built for generating data, inserting, changing, deleting records, and those sorts of things. So it has a very different purpose. If you've got a highly performing SQL database already where you can basically call any data point and it appears on your query screen in sub-second time, then there's no reason why you couldn't use direct query. But then some of the other capabilities that come with import mode are things like calculated columns and summary tables, all sorts of different things that you can do in an import model. But yeah, the whole idea of it is to get the benefit of better performance with the real-time data at the same time.
There you go. There's one other question. I think I'll probably just, you can see the chat, yeah? I'm assuming so. I think I might just let you deal with that one. So the question is, if I have budget for fiscal 2022 and actuals are starting to come in, same fact table, it'll still reload the same budget numbers for subsequent months. I think I'd need to see the model.
Yeah, so I mean, the typical, yeah, I mean, typically budget numbers. Well, in my case, I've got budgets here in the model that I had before. But so if I was to look at this AdventureWorks model here and try and apply that question, in my case, the budget table here is a finance generated table. So it would be in Excel and we've loaded that up into our model. But if we were to apply hybrid tables, this sales table would be made up of the historical data that's been loaded incrementally, plus any new data that's come in since the last refresh in the morning. So that's not going to have any impact on the budget data itself, because the budget itself is static. Now, some businesses will set a budget and then they'll set like a forecast. So the forecast can change throughout the year because they're not sure whether they're going to make budget or not. But the budget itself typically doesn't change. So yes, I think it would work that way. So and so if the budget numbers were on refresh mode, they're not going to need to refresh on a daily basis. You could even set that for incremental refresh, I guess. Although if I was going to do that, I'd probably use something like data flows. If you have different tables with different refresh frequencies, you can also use data flows. So load the budget table up into a data flow, and then that way you don't have to sort of interrogate the source every time. You still have to load it from the data flow, but you don't have to interrogate the source. It's particularly important if you've got a lot of transformation in your tables and the data doesn't change.
Absolutely. Cool. I don't see any other questions on that, Matt. So I just want to say a big thanks to you, bud, for getting a short notice call for doing this, and for popping in from your vacation home to come and deliver this. We really appreciate it. It's not every day I make a call like that to you, but I it's awesome that you were able to be here with us. So, and hopefully not the
no worries. So this is what I'm missing out on. Yeah. Sure, I showed this to Ken before. So this is the front of my vacation house. So that's why I want to go and get outside and go for a spin on my jet ski. I do want to just make one comment I saw in the comments from Sebastian, which is a really good point, is around sparklines, saying that if you've got some sort of ordered category, it would make more sense. So something like sizes or age groups or something like that. It would make sense to use sparklines. So you can imagine it's sort of almost like building a histogram. If you may have seen, say, if we talk about COVID cases, often you'll see them spread across age cohorts, 0 to 10, 10 to 20, and so on. So that type of sparkline would make perfect sense. So I totally agree with Sebastian's comment there.
Awesome.
Okay.
All right. Well, thanks, man. Appreciate it. You get back to jet skiing and enjoying your summer. And Joseph, it's all yours, man.
Talk again. Over to you, Joseph.
All right. Cheers. Thanks, Matt.
All right. Let me just start sharing, and we'll be good to go. And are you okay to monitor the chat throughout, Ken?
Yeah, I'm happy to monitor the chat and interject at the worst possible moment. Absolutely, not a problem there.
That's totally fine. That's always the way. There we go. Are we okay?
Yeah, I can see your screen. You're good to go.
Let's do it. All right. So thank you, Ken. Thank you, Matt, especially for filling in with the what's new in Power BI this evening. Python integration in Power BI, super excited. Sort of kicking off 2022. It feels, well, really recently that I was presenting at this meetup group last year, but I think it was actually in March or April. So it has been a little while. But with Python integration in Power BI, it's something that I'm really passionate about. I've done a few presentations on R and R integration in Power BI over the last few years, and it sort of follows a similar concept, I think, that it really allows us to incorporate advanced analytics from an external programming language into Power BI. And this allows us to extend the functionality of Power BI, incorporating sort of like data science, more advanced elements into a report so that we can share it with others within a tool that they are already comfortable using. So that's sort of, I guess, the main takeaway from the presentation today. But just before we jump into Power BI or into the presentation, just a little bit about me to start. So my name is Joseph Yeates. I'm currently a senior financial analyst for the Business Intelligence and Data Analysis program at Corporate Finance Institute. So I use a wide range of tools from SQL Server, Power BI, Power Query, and Excel, R, Python, I guess now, to model, manipulate, analyze, and visualize data. I have my website up there, feathersanalytics.com, where I have my blog. And I blog a lot about Power BI. But as I mentioned before, I have a few posts about R and then that integration as well. And I think that's really where my passion lies, is taking some of those data science elements and making them more accessible to a wider audience. I also have my Twitter and my LinkedIn handles up there as well. So please feel free to connect. If you have any questions for the presentation today, or just want to connect and chat about anything to do, sort of data stuff, I'm always really happy to chat. And please do reach out. All of the files for the presentation today, so the slides, some of the Power BI, some of the Jupyter notebooks, I will publish them all on my website, at a page on my website, and I'll make sure to link that to the Meetup group either later tonight or tomorrow morning. So they're not there yet, but they'll be there very shortly. A little bit of an agenda for today. So we're going to start with getting started in Python. So I'm going to cover sort of some of the different versions of Python that we can be using, where we can download it, and how we get prepared to actually integrate Python with Power BI. And then we'll cover that integration as well. And then we're going to be covering in the next section 3 ways that we can incorporate and integrate Python with Power BI. In the Power Query editor, we can use a Python script as a data source, but also as an applied step in a query to transform our data. And then in the report canvas, we can build custom Python visuals that we can use alongside sort of our standard Power BI visuals as well. Then in the second half of the presentation, I'm going to cover a machine learning case study. So we're going to be reviewing how we can actually build a basic classification machine learning model in Python. Then we're going to bring that into Power BI, and we're going to visualize the results as well. So really full agenda for the evening, but really excited to get started. So I think with that, getting started with Python. So the 3 things that we need to do to get Python set up to use within Power BI.
Before you get started, Joseph, hang on one sec, man. You got a quick question already, and I think it's probably relevant to this part here. How long did it take you to actually switch from programming in R to Python, like to learn language and whatnot?
I don't know. That's a tough question so early. I think the concepts are similar. I think if you're using it for data analysis or data science, if you understand conceptually some of the main points of data analysis, then that allows you to really focus on specific packages or libraries and learn sort of, I guess, focus your learning on things to get tasks done. And then I think the learning curve is not so steep. It's really just learning syntax. And really same thing for the data science side as well. If you have a good grounding in kind of like regression, classification, clustering, so some of these foundational aspects of data science, then yeah, if you understand that, learning the syntax, I think is, same with learning any language. You just have to get used to it and sort of get the reps in and put the time in. I think if you're learning data analysis at the same time, it can definitely be tricky because you're sort of training your brain to work in a new way with a programming language, as well as learning some of these concepts. But I think, if you programmed in R before, making the switch to Python is, I know it was sort of daunting for me for quite a while, and it was sort of on my to-do list and I kept putting it off. But once I actually jumped in and got down to it, it wasn't bad at all. Was that enough of a non-answer? Was that okay?
I'm thinking so, yeah.
Okay. Fair enough. Am I okay to move on?
Yeah, I think so. I mean, there's other questions that are coming in, but I mean, we obviously want to give you time to get through the presentation. So I would say continue on with what you got first, and we can always circle back on these.
Perfect. Sounds good. Yeah, so I guess first step to get started in Power BI, actually downloading Python. I'll cover a few different ways we can do that. We need to, for the actual integration with Power BI, there's two Python packages that we need to install. So I'll review how we can do that. And then we actually need to set up that integration of Python with Power BI, and I'll show how we can do that configuration from within the Power BI desktop application. So if I go into my browser here, there we go. Right now I'm on python.org download page, and I think this is probably the easiest way to get started with Python. You can go to the download section, you can look at the source code if you want to, and then you can choose either the most recent version or a previous version of Python for whatever your operating system is. The reason I say this is the easiest way is because if you're looking to use Python specifically to integrate with Power BI, this is the method that I'm going to be using throughout the presentation. And it plays really nicely. You just need to download it. I'll go over some of the packages we need to install, and then you can set it up right away. Another really common way that you can get started with Python, and where I'm actually going to be doing my Python coding for this session, is using Anaconda. So Anaconda is really like a data science toolkit. The individual edition, as I have up on the screen here, is free, and it allows you to code in both Python and R. It's a simple download. It makes sort of managing your environments really straightforward. And I know this is a really popular tool for data scientists to use to code in Python. So specifically for the integration with Power BI, I'm going to be using just a downloaded version of Python for python.org. But for doing my coding and for loading my Jupyter notebooks, I'm going to be using Anaconda. And once we actually get into it, I'll explain the reason for why I'm doing that. I've also included some documentation here. These links are going to be in the next slide and will be available to download. This covers getting started with installing some of these Python packages that I'm going to go through. So in fact, if we do this now, so assuming that we've downloaded Python, the two packages that we need to download to use with Power BI are pandas and matplotlib. So pandas is a popular package used primarily for data analysis, and matplotlib is another popular package typically used for data visualization. So we need to install both of these before we can start integrating with Power BI. Here are the links of the sites that I was just going through. And so yeah, these two packages, pandas and matplotlib, and then the code that we can just copy and paste into the command prompt is here. So if I just pull up my command prompt here and drag it onto the screen, all we need to do is copy this code, paste it in, and then this will install these two packages for us, pandas and matplotlib, and then that allows us to move forward to set up the configuration in Power BI. So this is a really important step. This is a really important step in that process, and you won't be able to use Python within Power BI without installing these packages. The last step to set up the integration within Power BI itself, if you go to File and then Options and Settings, Options, when this Options pane comes up, under Global Options here, right under R scripting is Python scripting. And then we have to set up the detected home directory. So if I hit the drop down here, we can see that I have Python version 3.9, which would be what I just downloaded from python.org, as well as Anaconda. So if you have both, or if you're just going to choose one, would definitely recommend Python. I think they're actually on version 3.10 now, but you have to choose that here. And one thing that's not in the presentation today, but something that you can do as well, is actually link Power BI Desktop to your integrated development environment for Python. So you can either leave it as the default, as the operating system program default for Python files, or you can choose and browse for another one. But the most important thing for getting started with Python and Power BI is setting this home directory here. If you have Python downloaded, it should automatically detect that for you. But if not, from the drop down, if you have a few different, would recommend going with whatever version of Python you downloaded. So I think with that, now that we have that set up and we've covered those aspects, we can start actually getting into Power BI and into some of the programming. So if I pop into the Power Query editor here, the first way that we're going to look at with Python is using a Python script as a data source in Power BI.
Joseph, can I interrupt you again?
Sorry, go on. Yeah.
We got about 3 questions that are sort of all floating around this thing here, around the using the Python IDE, or can you integrate Python with a specific virtual environment? VS Code's been thrown out there. I know that was a quick note that you said you weren't going to look at, but I think that there's a lot of questions there right now. So,
sorry, that was around the linking the IDE.
Yeah, can you integrate Power BI with a specific virtual environment or with a specific IDE?
Yeah, I've not gone and sort of. Can I come back to that in a little bit?
Yeah, absolutely. I'm going to be honest with you. I'm having a hard time with this one because I know zero about Python, and the people that are in the chat obviously know something about it, and they're putting words in here that I don't even know what they mean. So, so just so you know, for Jennifer, who seems to be answering some of these questions, I appreciate it because I can't really even tell what needs to be referred to Joseph in this because it's so different than the world that I've been playing around with. So, apologies there.
No, yeah, no problem. I think there's yeah, a little bit later on, I'm going to come to probably a more appropriate area to or time of the presentation to talk about that.
Sounds good.
Yeah, I'll but yeah, I won't forget. I'll definitely come back to it. So to use a Python script as a data source, if we go to New Source in the Power Query editor, under More, this gives us the list of all of the different data sources available to us in Power BI. So we can either type in Python to the search box, or under Other, about halfway down, we see Python script here. So if I hit Connect, this brings up, kind of an uninspiring blank white box with a little cursor blinking at you. And it is possible to start coding here. But it's not really my preferred method, is to start just coding within Power BI itself. And there's a few reasons for that. And really, it just comes down to it's easier to start coding in an actual code editor or in an IDE, sort of an external IDE. And then we can just paste that code that we've written into Power BI. Using these different applications allow us to take advantage of things, like syntax highlighting, debugging, automatic formatting, which isn't available to us in Power BI for Python scripting. So at this point, I'm going to jump into a Jupyter notebook in Python. So to do that, I'm going to use the Anaconda Navigator. So I've downloaded Anaconda. It looks just like from the website that I showed earlier. And I'm just going to launch a Jupyter notebook from here. And what Jupyter notebooks look like when I click on that link is it brings up something like this, actually. So I'm just going to navigate to desktop, and I have 2 Python notebooks already set up for me. So I'm just going to start with the Python integration. Just as that's loading up, I think one thing I skipped over was, if I'm using Anaconda to actually do coding here with using Jupyter notebooks, why don't I use Anaconda why don't I integrate that with Power BI? And I think the reason is that it is possible, but it is much trickier to set up, and it does require some custom coding in the command prompt. So it is possible to run 2 different instances of Python concurrently on a machine. And for the presentation today, it really just gets us up and running a little bit quicker. So, I will be flicking back and forth between the 2. Most of the code we write, it can be run in both. And I think that I've kind of intentionally not got into the details of all the different options that we have for the integration, which of course is what all the questions are about. And I do understand that. But maybe a little bit later on, if we have time, I'll get into a little bit more detail. I'll definitely address it, but really that's, I think, the main reason I've not got into all the different options of the different development environments that are possible. But to the first Python script that we use as a data source in Power BI, we're actually going to create data manually. So to do this, the first thing I need to do is to import the pandas library. So with any Python is an open source language. It does have some core capabilities, but we can go way beyond that by importing different packages, and that provides us different functionality to use as we're programming. So as I mentioned earlier, pandas is a really popular data analysis package and is one of the required packages to integrate with Power BI. So the first step is importing this pandas library. So I can import pandas and a common alias of the pandas package, if you're looking at any Python code, is PD. So every time you see PD data frame, I'm just specifying that I'm using this data frame functionality from the pandas package. Then in the next step here, I'm defining the create data frame object using data frame from the pandas package. And in the rest of this code, I'm specifying what I want the column name to be. So I have grade, price, and state. So this data frame is going to have 3 columns. And then I'm defining all of the different rows and the values within those rows for the rest of the data frame. So we have A, B, B, C. We have some numeric values for price, some text values for state. And then if I want to have a closer look at this data frame, I can use the print function to print the create data frame. And then when I run this section of code, we can see the output here. So if we actually want to create any data manually with Python, I can just take this code, copy it, head back into Power BI, paste this in here, and hit OK. And then when this runs, in this navigator pane here, we can see that we've defined this create data frame. If I click on it, we see the preview. It looks like exactly what we did within the Jupyter Notebook. So I can click on that element and hit OK. Let's zoom in a little bit here. So one of the reasons why we used pandas is not just because it's such a popular package, but the reason why we're actually using that data frame function is because a pandas data frame is the only data structure that's recognized in Power BI. So if we were to define some lists or tuples or matrices or other data structures that are available to us in Python, we could have that with the code, but then if we were to try and bring that into Power BI, it wouldn't recognize it. It needs to be structured as a pandas data frame. And since that's how we structured our code, it is recognized, and we can import this data and use it as a data source, just like other data sources in the Power Query editor. For our next example of going through and using Python as a data source in Power BI, rather than just sort of like typing in data and manually having to define the data that we want, we can use some Python libraries to actually connect to and bring in external data as well. So to do that, I'm going to use a package called Data Reader. And we're going to do this to import some stock data. So there's 4 arguments that we need to use this data reader function. The first is the actual stock that we want to bring information in for. So in our case, this is going to be the S&P 500 index. We also need the data source we want to bring in the stock information, which I'm going to use Yahoo Finance. And then we need a start date and an end date for the range where we want to bring in this daily stock information for. So the first thing I can do is actually set these date parameters. So if I set start date, we can say this, we want this to be equal to the start of 2020, like that. And then we can set an end date as well, and we can set that equal to the end of 2020. We'll just do one full calendar year. Then to actually import this stock data, I'm going to create an object called stocks data frame. And we'll set this to be equal to the pandas data reader using the data reader function. I want information for the S&P 500 index as the first argument. We want Yahoo Finance to be the data source. And then we can use these start date and end date values that we've defined up here to set what the start and end date is. And the reason why it's nice to abstract these values out and parameterize them up here is that if we need to ever change this, if we want to shift this to 2021, for example, I don't need to dig into the middle of a line of code in the middle of a function. It's nice and clean up here, and then it just flows down through our solution. And finally, if we want to take a look at the stocks data frame that we just created, I can run this block of code here. And end date's not defined because I have a typo. So if we run through this again, now we can see that we have a date column to the left, a daily high, daily low, the open and close price, the volume traded per day, and then the adjusted close price as well. So I can take all of this code, head back into the Power Query editor. Again, just have a new source as a Python script. Which if I type in Python, it should come up for us like here. And then I can paste that in, hit OK. And now, although we're using the Python script as a data source, that script itself is actually pulling in external data, and then we're loading that script into the Power Query editor, into Power BI. Here we go. A little slow. Maybe some of Matt's connection's rubbing off on me. This is running a little bit slow this evening. So I'll bring in that stocks data frame. And we can see the high, low, open, close. So all the same columns that we saw in the Jupyter Notebook. But one thing that you may have noticed is that the date column isn't here. If I go back into the browser, we can see date here, but not in Power Query. And this is a really important concept because the date column in this data frame is actually an index. It's an index for the data frame, and it's not actually a part of the data frame. If I scroll up to our previous example, indexing in Python starts from 0. So this first row here has an index of 0. Row 1 has an index of 0. The second row has an index of 1, and so on and so forth. But this index doesn't get imported into Power BI by default. So if we do want to bring in date and have that as a column available to us, we need to explicitly create this column and add it to the data frame. So to do that, I can take our stocks data frame. I can add a new column called date. And we want the value of this date column to be the index from our stocks data frame. So now if I run this again, we can see that date is still the index over to the left here, but now at the end of our data frame, we have an additional column of date. So now if I just take this line of code, head back into the Power Query editor, I can hit the gear icon that allows us to edit this source step. I'll just paste it at the bottom here, hit OK. And then when I click back to the next navigation step, when that's loaded, date is now going to be available for us to use. Just as that's loading out there, Ken, is there any questions sort of about this section of the presentation?
Well, this is a good question. So there's a question on does Python script perform faster than traditional M language in Power Query?
Does it perform faster?
Yes.
Is the question. As we can see with this, I don't think it performs faster. I mean, the Power Query editor has been optimized for M, so I mean, I think using Power Query is still the way to go. I'll get into it in this next example coming up, but I think using Python is great for sort of problems that are typically really difficult to do with M in the Power Query editor. If we can do it with Python more easily, then yeah, I mean, it still performs well, but I'd say that yeah, M still performs better in the query editor.
Okay. Next question is, every time you're writing something, you're writing it in Jupyter and then you're bringing it back and pasting it in Power BI. I'm just going to guess on this one, that's just because you actually get the chance to test it a little bit easier over in Jupyter, and it's just a text editor in Power BI. Is that right?
Exactly. Yeah.
Okay. There is one other question in here which I'm trying to figure out whether or not this is appropriate to ask at this point in time or not. So you can defer if you like. But Jennifer asked us a confirmation on PD data frame. She says the visual uses, and I believe the word is numpy arrays in the data set. I believe you specifically called out data frames. Are those the same? Are they not? I'm not 100% sure exactly what this is about. So
yeah, NumPy is a different popular data package, or a popular library rather, in Python. I may have to come back to that question or take it offline, sort of at the end of the session.
Fair enough.
Yeah, if that's okay.
And then of course, Charlie is going to ask just the devil's advocate question, which I think is fantastic. For the stock import examples you just did, could you use Excel's new data types instead and import that to Power BI?
Yes and no. I think you could do something very similar. I have played around with that. I've not actually done a direct comparison, but I will say that using Python, in my experience, gives a lot more reliable results. I know sometimes it gets a little bit funky with the stock complex data types in Excel, but yeah, I think overall you're going to get, for sort of big stocks, you're going to get the same information. Yeah.
Last question for this section here. Are you going to reserve some extra time at the end for Q&A? Well, that depends how much I just back you right now, right?
I think for sure, and I mean, to be honest, I think I might have to start deferring all the questions to the end if we're going to get through.
Okay. Yeah, let's do that for right now. We'll save Q&A for the end, and let's
Perfect.
Unleash you to get through it.
Cool. Thank you. And I mean, it's thank you everyone for all the questions. This is fantastic engagement. I just want to make sure I get through the whole presentation before 10 o'clock tonight. Perfect. So kind of picking up where we were, now we have the date column available to us in our data set, and we can do the usual, regular applied steps in Power Query. We can change the data type. We can, change the order of the rows. And in fact, one of the tips I picked up from one of Ken's last presentations, which I love now, we can just do detect data type on the whole table, and then we're ready to go. So if I just flip back into the slides here we go. So those are the three things we're going to do. Yeah, so only pandas data frame is recognized in the Power Query editor to import. I can touch on that in the Q&A at the end of the session. And that an index column as part of a data frame is not imported by default. So if there is information in that index column that we want to bring in, like there was in our example of the date, we do need to actually define that explicitly as a column in the data frame, and then we can use that within Power BI. So for our next example, we're going to be using Python not as the data source of a query, but we can use a Python script actually as an applied step within a larger query. So for our example, we have a list of student exam scores. We're going to have a column of student identifiers and then a list of the scores that those students had on an exam. And what we want to do is to assign each student to a percentile. So that means that we have a few different steps in order to achieve this task. We need to define which percentiles that we want to calculate, so where we want to cut off these different percentiles. Then we actually need to calculate these percentiles across all of the exam scores of the students. And then finally, we want to assign, now that we've calculated the percentiles, we want to assign each student to their percentile, where they fall into compared to the rest of the class. So if I head into the Power Query editor, I've started that here. So we actually have 3 columns. We have a numbers column, which is essentially just an index. We have a student column with students 1 through 20. And then we have a score column with scores range from just under 5 to like 94. And we can see that, I have some applied steps in our query that's created this information. And we're at this point. And if we were to approach this task of creating percentiles and then trying to assign students in Power Query, it might be possible. It would probably take us a long time, some Googling, looking at some blog posts to figure out. But it is a lot more simple to achieve using Python. So I think this is a great example of, you can use Python to sort of fill in some of those gaps where it's more difficult to achieve the same thing with just M in Power Query. So if I go to the Transform tab on the ribbon here, we can see that I have the option in the far right-hand side to run an R script or to run a Python script. So I'm going to select Run a Python script. And by default, right at the top, we can see that dataset holds the input for this script. And this is really important because now we know that to use this data that we see here in preview in the Power Query editor, we need to reference dataset in order to access the data that we see in preview. So I'm going to head back into my Jupyter Notebook now to start building the solution in Python, and then we'll bring it back and we'll paste it in here and continue on in Power BI. So if I just scroll down to our example here, we can see that I've already run this code and I've used pandas, I've used NumPy. All I've done is to create the exact same data set as we saw in the Power Query editor. So to create the first step, as we saw in the slides, is to define the percentile parameters that we want. So in this example, we care about 4 different parameters. We care about the 50th percentile, the 75th percentile, the 90th, and the 95th. So I'm just storing these 4 numbers in a list, and we're assigning this list to this purse object. Perfect. Then what we can do in Python is that we can actually create a for loop. And what that means is that instead of explicitly defining the percent, like the 50th percentile, the 75th percentile, the 90th, and the 95th, instead of doing each of that work 4 times and then just having to copy paste our code and to repeat that logic, we can create that logic once, and then we can loop through this list and we can calculate the 50th and the 75th and the 90th and the 95th percentile. And it's a really efficient way that we can code without needing to repeat and copy and paste. So write a for loop, I can say for, and I'll just use I in purse. So this is saying for each of the individual items in this list. Then we end with a colon. And I'm going to say we're going to use the percentile function, percentile, from NumPy on the score column from our data set here, because that's the column we need to create the percentiles for. And the percentile that we want to calculate is I, which is this individual item in the list. So we're going to calculate that percentile and we're going to store it in J. Then what we want to do, now that we've calculated those percentiles, is we want to add each of those as a new column in our data frame. So right now we have 3 columns. We want to add 4 additional columns that hold the value of the 50th, 75th, 90th, and 95th percentiles. So to do that, I'm going to create a new column in our data set. And we're going to take the string. So this is transforming this number into a text. So we're going to take the text value of this item in the list. And then we're going to name the column that item plus percentile, like that. So this is going to be the name of the column header. It's going to be 50 percentile, 75 percentile, 90 percentile, 95 percentile. And then what we want to populate all the values of those columns is J here that we just defined. So now I can print out our data set. So I'm going to print data set here. And now when I run this code, oh, data set's not defined. Let me run it here first. And then here. And now we can see that just with, just a few lines of code, we've been able to create 50th percentile, 75th, 90th, and 95th. So 4 columns really quickly and really efficiently using Python. But we're only halfway there, because although we've created these 4 percentiles, we wanted to assign each of these students to their relevant percentile. So to do this, I've actually written this code already, just so we can do a little bit of a walkthrough instead of actually typing all this out. But to assign each of the students to their percentile, we need to create, or we're going to use a function from NumPy called select. And what this select function does is that it matches a list of items to a list of conditions. So those are 2 things that we need to define. We need to define the conditions, which I've done in here. And we're simply testing if the student score is less than the value of the 50th percentile column, or if the score is less than the value of the 75th percentile, or less than the 90th, or greater than or equal to the 90th to get them into that 95th percentile. So those are the conditions that we need. And then the actual items that we want to match to those conditions are the values from our percentiles list here, but we need to convert them to a string. And so to do that, I've just written a really short block that for every item in the percentiles list, I want to take the string value of that. And the reason why I'm converting this to a string is because this NumPy select is like a text function, I guess. So it can't take on a numeric value. We need to convert it to a string. So if I take this block of code, and I'm just going to paste it underneath here. So we've defined our percentiles, we've created our columns. Now all I'm doing is creating 1 additional column that assigns each student to one of these percentiles. When I run this code here, we can see we have an additional column, student percentile, and for each row in the data frame, they're assigned to either the 50th, 75th, 90th, or 95th percentile. And then we're ready to copy this back into Power BI. And just, if we look with writing, abstracting out our 4 percentiles that we want, writing a for loop, defining our conditions, and then matching each student to those conditions, we've created 5 columns, and this would probably have taken us a lot longer to do in using Power Query, using just M in the Power Query editor. So if I take this block of code here, and if we head back into Power BI, I can paste that in like that, hit OK. And then when that's running, we're going to see that just like how we did in the Jupyter Notebook, we're going to create some additional columns here. So we have just data set. We have the table that we've created the data frame, the pandas data frame that we created here. And then when I drill in, and it pulls up the data transformation that we've done, just being a little bit slow. Oh, sorry about this. I don't have the excuse of tapping into a satellite. It's too much going on.
Maybe Matt broke it just by joining. It's still looping through Australia.
Yeah, exactly. Just tagging in there. Here we go. Something's happening. Here we go. So we can see that we've added all of these columns on to our data set, and we have assigned each of the students to the percentile. And what's great about this is, we can see we have a bunch of applied steps in our query before running this Python script. And if I wanted to, I could do further manipulation. Like I could, like remove these columns that we created if I don't need them. But we're able to do some applied steps before the query, or before the Python script. We can run the Python script, and then we can build on top of that as well. Like, we don't need to do everything in Python or everything in Power Query. We can really combine the two. And if I head back into the slides, now that we've done that, data transformation, the last thing that we're going to look at is creating visuals in the report canvas in Power BI. So what we have here, that's getting a little bit ahead of myself. Let's go ahead back into the Power Query editor. I'm just going to disable load for this basic example, but I'm going to hit close and load. And we're going to take a look at the stocks data frame that we defined. Perfect, there we go. Oh, I'm still working on it. Okay. So for our stocks data frame, so as we did in one of the previous examples, we used a Python script to pull in external data, and then we've loaded that into Power BI. And we can use this just like any other data source in Power BI. I can pull in date onto the axis of a visual. We can look at volume, say, as the values here, volume by year. I think is this if it loaded properly. There we go. Okay, no, we do have values. There we go. It's just a little bit slow to render. Okay, yeah. So we can look in at volume by like quarter of the year. We can create a line chart. We can look at the high and the low value by date. So rather than a date hierarchy, we can look at a continuous date range, something like this. And if we wanted to complement or supplement these visuals, these standard Power BI visuals, we can also build a Python visual. And to do this, in the visualizations pane to the right of the report, I can click on this pi symbol, and this shows that it's a Python visual. So I'm going to hit enable. And the first step, automatically it pulls up this Python script editor, and we're prompted to drag fields into the values area in the visualization pane to start scripting. So what that means is, just like any other visual in Power BI, we need to drag some columns from our various tables of our data model from this field section into this visual section here. So I'm going to pull in volume, adjusted close, and I'll also pull in, what will I pull in? I think I'll just pull in those two for now. And if I head back into our Jupyter notebook, I'm actually going to start coding here exactly what we need to create this visual. So the first thing that I'm going to need to bring into Power BI is the matplotlib library. So I'm going to import matplotlib. And then I need to create the plot. So I can take our data set that we had defined, the data set, back in Power BI is the same thing that we saw in the Power Query editor. So by default, we're setting this value of data set to a pandas data frame that was created with these fields that we dropped in here. Another important point of note, which I'll emphasize a little bit later in one of the next examples, is that by default, it also drops duplicates. So that's important to note too. But if we head back into Python, on that data set object in Power BI, I want to build a plot. And the columns are adjusted close, volume. I want adjusted close on one axis, volume on the other, and the type of plot that I want to create is scatter. So once I've defined this, you may think that, okay, this is all we need to do. We've defined our x-axis or y-axis, the type of plot that we want to visualize. But one important thing we need to do is make sure that we actually show this plot, because right now we've just defined how we want it to look. We've not kind of told it that we actually want to display this plot. So to do that, I'm going to use pyplot show. And actually, I'm going to import just pyplot from matplotlib. So if I copy this code here, head back into Power BI and paste it in, I have to hit this run icon in the top right-hand corner of this script editor within the Python visual. And once I do that, we get an error message saying we can't display this visual. So we can see details. No module named pyplot. I think I must have typed in that wrong. I got these the wrong way around. From matplotlib, import pyplot. There we go. Paste that in and then run it. And then if I just minimize this for a second, we have a scatter chart, but with only one point. So there's only one thing here, right? And the reason for that is if we look at volume, by default, we have a summarization. We're actually summing volume. And so if we set this to don't summarize, and we set adjusted close to don't summarize, then if I open this back up and run it again, we see that we have a scatter plot here. So two things to look out for when we're using Python visuals within Power BI is making sure that we're not summarizing these elements if we only have numeric elements. Really make sure we know, sort of what implicit aggregation is going on, and also be aware that we are dropping duplicates by default. So if we have two rows that are the same in a data frame, we're only going to be showing the results for one of them. So you may need to bring an index column into the visual to make sure that they're not being removed by accident. Back to the slide. Yeah, so the two important points of note, pyplot show is needed to actually display the visual. If I didn't have that line there in the code, we're basically defining what we want the visual to look like, but we're not displaying it. And then important to note that duplicate data is removed by default. So we're kind of at the, maybe just over halfway point in the presentation. I was going to jump in and go through an example of building a machine learning classification model, but we are probably like 20 minutes behind where I was aiming to be by this point. So what do you think is best, Ken? Do you want to open it for a Q&A and maybe I can do a recording of the model section, or just go ahead and we'll be here for a little bit longer?
We've got our first vote for go ahead. So, you know what, Joseph, by all means, I mean, if you've got the time that you want to or can dedicate to it, then if you want to stick around, I'm sort of happy to let you do that. Sure. I am going to interrupt you with one question before you go on, just so we can, because I think most of the questions have actually been answered along the way here in the stuff that you did. Okay. But there's probably two. So number one, can you use measures instead of columns for plotting Python visuals?
Well, let's see. I believe you can, but why don't we test that right now? Let's create a total volume and see if that works. Is there another question as I'm just...
The other question, if I'm reading things right, because these guys are throwing out terms like crazy, like it's like looking at gamers with different things, or snowboarders with their funky terms they come up with. But I believe what we're referring to here is a bunch of different libraries, and it looks to me like there's a fairly good discussion here about what libraries people prefer to use versus what does Power BI actually support. And I know that Jennifer had thrown in a list of what the supported visuals were earlier. Do you have any commentary on that at all, or no?
There is a list, and I'll add that to my sort of helpful links page in my presentation that I'll upload to the Meetup group. There is Microsoft documentation of all the different libraries that Power BI does support. Yeah, so that document does exist, but I will say that like it's mostly just the the very popular ones. It's the same thing on the R side. A lot of the packages from the tidyverse are supported. On the Python side, we have pandas, numpy, matplotlib, some of the data science packages as well. Yeah, like if you're using really common ones, you should be totally fine using them in Power BI.
I think Jennifer's comment here was that you can use anything you want if you want to do it locally, but if you decide to deploy it to the service and want to get a refresh or whatever else, then it must be one of the supported ones.
Yes, yeah, exactly. Sorry, yeah, I was thinking of publishing, but yeah, you're totally right. Locally, for sure, anything that you can run on your machine, you're good.
Pranam has just thrown a comment to you that says, I think volume needs to be replaced with total volume in the code.
Yeah, just done that. So yeah, it looks like measures work for sure. Perfect,
awesome. Yeah. All right, I'll mute myself then, and we'll let you soldier on with the next round.
Sounds good. All right, let's head back into the slides then. So machine learning, so building a simple classification model in Python, and then we're going to bring that into Power BI. So the first step that we're going to do is we're going to use the iris data set. And I think anyone, and there does seem to be quite a few attending the session who are familiar with Python, might groan a little bit. Iris is kind of like the adventure works. It's a very, very common data set. It's used all the time. I think everyone's very familiar with iris. If you've done any sort of intro to Python, same as doing adventure works in in SQL or in Power BI. So we're going to load this data set, and we're going to inspect it a little bit in our Jupyter notebook. And then one thing that we're going to need to do is that when we just load iris, it's actually a collection of different arrays, which works totally fine when we're doing stuff in our Jupyter notebooks. But as we said before, to bring that into Power BI, we need to transform it into a data frame. Otherwise, we can't bring that into Power BI. So we're going to need to combine and transform a few different arrays into an actual pandas data frame so we can bring it into Power BI. And then we're going to run the classification model and then visualize the results. Or we're going to run the classification model. And then what I mean by that in a little bit more detail is we need to define within the model the target. So like, what is the thing that we're trying to predict? Like, what is the classification that we want to try and build? And what are the features? So this is what are the columns of the data set that we're going to use to make the prediction of our target variable or our target column. We're also going to create a train and test split in our data frame. So this is best practice that we're going to split the data set instead of training our model on our entire data set and then generating predictions. We're going to split our data set into, in this case, 75% training, 25% testing. But you can have 2/3, 1/3 split. And the reason we do this is because we can use this test part of our data set. So like 25% of our data set we can use to actually test the model that we've created and trained on the other 75% to see if it still performs the same and actually measure the accuracy of the model. Is kind of acting like future data or unseen data that we'll get in the real world. So after we've created these splits, we're going to fit or train the classification model on our training set. We're going to generate predictions, and then we're going to visualize the results of the model in Power BI as well. So if I head back into the browser here, I'm actually going just to close this notebook. We're done with that one. And we can open up the classification model. I'm just going to close all those tabs as well. Okay. So our first step is to connect to the iris dataset. So I'm going to import load iris from the scikit-learn datasets. So we're going to load iris, and then we want to have a look at how it looks like as well. The two main things that I want to see are the feature names. So again, these are the column names that we're going to use to try and predict what our target is. Then we need to reshape iris, and I'm going to do some further manipulation. But why don't I take some of this, and we're just going to copy that down there for now. But why don't we just print iris after we load it? And I'll comment these two lines out for now. So all we're doing is importing the libraries we need. We're loading iris and storing it in an object called iris, and then we're going to print it. So I'll run this. And then we can see the result. So we see that we have data, which is an array of lists of 4 different values, it looks like. I scroll a little bit further down. We have a target object, which is an array, and it's a very long array. Goes all the way to here. So we have 2 arrays. We have a data array and a target array. And then we have, a lot of information. It's really messy to see, and that's why instead of printing iris, if I comment this out, why don't we just look at the target, the feature names and the target names? So we'll run this instead. And so we can see that the 3 target names are here. So these are the 3 classes available to us in the data set that we're trying to predict and build our model, build a model to predict what class it belongs to. And these are the 4 columns that we're going to use to build that prediction. We have some petal length, petal width. So this is to do with flowers, I should say. Petal length, petal width, length, 4 different columns to predict 3 different classes. Okay. So we saw that we had a data array and a target array, but we can't bring arrays into Power BI, so we need to create a data frame. So what I'm doing here is I'm defining the data of a new data frame that I've called classification data frame. And to combine these arrays, I'm using a concatenate function from NumPy, and I'm concatenating the data and the target arrays that we just saw when we printed out. Then the names of the columns are the feature names, so that we just saw here. And then the last column name is target, because these are the actual values of the different target. So if I take this, let's paste that up there, and then we'll print the classification data frame. Let's get rid of these two, and then we'll run this code. So now we can see, you know, it looks a little bit nicer. We only have 5 columns. We have a target and these 4 feature columns. We have 150 rows. I know it says 149, but remember, indexing in Python starts from 0. So we have 150 rows, and then we have our target column as well. But if we look at target, this is actually, we have numeric values in target. We have 0, 1, and 2. And really what I would prefer is to have the feature names we saw earlier, like the actual text description of what our target is, what the classes are. So then when we're interpreting and running our model, it's a little bit more obvious as to what's actually going on. We don't have to remember what like 0 corresponds to or 2 corresponds to. And to do that, I can use this line here. I'm going to create a new column in this data frame called target name. And all I'm doing is saying, you know, when the target is equal to 0, replace it with Setosa. When it's equal to 1, replace it with this value, and 2, that value there. Just going to take this line, paste it underneath, and then when I print out the data frame this time, we can see we have the additional column here. So we can use target name on our model. So again, it's just a little bit more easy to deal with. Now that this is in a data frame structure rather than an array, what's nice is that we can do more data frame type functions on it, which is quite handy. So if instead of printing it, if I take our classification data frame, and if I wanted to like group by the target name column that we just created, so I want to group the 150 rows just by the 3 different target names, like that. And I want to look at like the average of all the other columns in the data frame, the feature columns. Data frame has no. I think I messed up the code somewhere. Let's see. Print. Did I spell target name wrong? I'm not sure. Okay, I think I'm having a typo somewhere that I can't see. I will come back to this later. Data frame object has no attribute group by. Okay. Interesting. Okay. Sorry. Yeah. Sorry. I'm going to move on just for the sake of time, but yeah, not sure where the typo in my code is there. But at this point, now that we've created this data structure here, we created a nice data frame of our 4 features, our target, and our target name. I can take this code and I can bring this into Power BI. So if I go back into Power BI, into the Power Query Editor, I can use this as an actual data source. So I'm going to go use a Python script as a data source again. So I similar to how we brought in the stocks data, connecting to an external data source, that's what we're doing here as well by using Iris. We're not having to type in the code and manually define what Iris is. The Python package is bringing that in. There we go. So I'm going to hit OK. And then when we make that connection, we should have our classification data frame available to us. And notice that we have the classification data frame because it's structured like a pandas data frame, but Iris, which when we first imported it, was just a collection of arrays, isn't available to us to actually connect to and bring in. So that's why we had to go through that reshaping process. Oh boy. Here we go. So I can bring in the classification data frame that we'd reshaped and built. Let's drop this into our classification here. Nice. Perfect. So I'm ready to paste that code in. So now we have our data set, which we built in Python, brought that into Power BI. And if I head back to our notebook, we're ready to actually build the model. So we'll do that here. We can train our classification model. So I'm just going to do a quick walkthrough of the actual model build because it's not really the focus of the session. But I'm importing the libraries that we need. One of the important things is this train test split, which I'll discuss in just a few moments. We're bringing in our decision tree classifier because that's the model we're going to use. We're making a classification model and pandas as well. So as a first step, we're just defining what the 4 features for our model are going to be, and we're storing that in a list. Then we're taking the data array from Iris, and we're saying that those are our features for the model. This is what we want to use to make a prediction. Then we're taking the target array from Iris, and we're storing that as our Y target. So this is what we're trying to predict. And then as the next step, we're creating that train test split on our data. So we're using train test split on our features and our target. We're defining a test size of 0.25, which means that the test split of our data set is 25% of our entire data set. So that means 75% will be held out for training. And then the last argument is a random state. And all this is doing is that because we're splitting the data into percentages, that split happens randomly. And so in order to be able to reproduce the results of our model and of our split, if we set the random state, this is also known as setting like a random seed, it means that we actually can make that split in the same place in our data set every time. And that way, when we rerun our model, we're able to get the same results every time. If we didn't have this, our split would happen in a random place in our data set each time, and our model may be slightly different each time because we've split the data in a slightly different way. But the output from this function, we actually have four different outputs. We have the training features and our testing features, and then our training target and our testing target. So we've defined 4 different elements just with this one function. Then I'm defining the classification model that we want to use, which is a decision tree classifier. And again, I've set a random state here just so that we can have reproducible results. Then we're fitting or training our classification model. So I'm fitting the model on our training features, trying to predict our training target, and restoring the results in trained model. And then finally, to our entire data frame, I've created a column called predicted target, and I'm taking our trained model and I'm making predictions based on the features of our classification data frame. And then I'm printing the results. So if I run this code here, we can see that we now have a new column. All of that only produced one new column, which is the predicted target. So we can see that we have the actual results of our target, 0, 1, or 2, and our predicted target of 0, 1, or 2 here. So at this point, I can take all of this code, I can copy it, and I can bring it into Power BI here. So I could have this all as our all part of that source script, And like I could update our source script here and paste the classification model in. But I'm not going to do that. I'm going to do it as its own applied step. And I'm really just doing that, for fun. And when I paste it in, one thing that's important to remember is that dataset is what holds the input for this script. So anywhere in our script where we have iris, for example, or classification data frame, I'm going to need to update to make sure that I'm actually referring to dataset, because this is what this is called. Although the query is called classification dataset, within the scope of this script within the Power Query Editor, we need to refer to dataset. So I'm just going to update that code here. I'm going to say dataset and dataset there. And so I've made that update, which is OK. And then below that, in our code here, when we created our train test split, we used this function, the train test split function. And so executing this Python code in Power BI will work correctly for sure. But one thing that I don't like about doing this is that this split just happens within the Python code, and we don't really get to see what rows were part of our training set, what rows were part of our test set. And it kind of gets lost within this code, and it makes it not really easy to audit within Power BI. So one thing that we can do instead, I'm just going to run that for now, even though it's not going to run properly. I'm going to get an error back. But one thing we can do instead is, as opposed to defining our train test split in Python, we can actually define that in Power Query before we run the script. So to do that, I'm going to add an index column from 1. And I do want to insert the step before our Python script. So now we have a new index column that starts from 1 and goes down to 150. But rather than index, I'm going to rename the column to split. There. And then since the train test split that we defined in our code was 25% of our data set we want to test, we want 75% to train. So we need to somehow split all of the 150 rows in our data set between training and test. And one thing that's important to note as well is that we want to make sure we do this split equally among these 3 different target classes. So we have 3 different targets that we're trying to predict. We don't just want to say, OK, let's split 40 something rows. We'll just take the first 40 rows. We'll put that in our testing data set. And then all the remaining 111 rows we'll put in our training data set. The reason for that is because that means that only 10 rows of this particular class of Setosa will be used to train our model. And then when we test our model, it's only going to be on a single class. So we want to make sure that not only are we splitting our entire data set into 25% and 75%, but we also want to make sure that that 25 and 75% split is pretty equal across the 3 different classes as well. And so because we've ordered our data set by 50, 50, and 50 for our 3 distinct classes, we can take advantage of this pattern when we're creating this train test split in Power Query. So from this index column, I'm actually going to use, I'm just going to zoom in a bit. I'm actually going to use a technique I learned from one of Ken's courses. I'm using it in a slightly different way than he demonstrated. But I'm going to go to the Transform tab on the ribbon, and I'm going to use modulo. And what this operation is that it divides the value of this split column by a number. I'm going to choose 4 because we're trying to split our train test data split into a quarter. So I'm going to use 4. I'm going to hit OK. And once it divides by this number, it shows the the remainder from that division. And we can see that we have this nice pattern all the way down our data set, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, all the way down to the bottom. And so what I can do is I can update this modulo operation, this calculation, and I can say that if the result of this is equal to 0, then why don't we define as our test data set, and otherwise or else we'll have it as part of our training data set. I just need to change the type to text. And then when I hit OK, we can see that we have every 4th row in our data set is part of our test sample, and then 3 of the 4 rows are our training sample. And if we want to be really make sure, I can take these 2 columns, group by, and then we can just count the rows. So I can hit OK. And we can see that we have, 38, 12, 37, 13, 38, 12. So each of the classes are equally represented between our training and our testing data set. That was just a quick check. I don't actually need that, so I'm just going to delete that step. But now that we've created this split column and we've already determined in Power Query that train and test split, we don't need to do that in our Python script anymore. So I can replace these lines of code here. So I'm just going to copy paste some code in. So our test data frame is when the split column of our data set is equal to test. Our training data frame is when the split column is equal to train. I was going to zoom in a little bit. Oh, there's my magnifier here. So that's how we're defining our train and our testing data frames. And then we're still defining those same features train, target train, and then features test and target test. As we did in Python using that train test split function, we're just doing it in a slightly different way, leveraging some of the Power Query functionality that we have since we're bringing this into the Power Query editor. So I'm going to hit OK. And now hopefully this should work properly because we don't have any more references to Iris or any of the arrays in Iris. We've replaced those references to the column that we just created in our data set. There we go. Oh, still running. So maybe the answer to one of the questions earlier about how's the performance of Python. When you're doing a live demo, obviously not well.
I can slow down Power Query pretty good too, though, all on its own. So I don't need Python for that.
Yeah, exactly. And here, rather than just having one output that we can simply navigate to, we actually have a few different things. We have our data set, the features test, features train, target test, target train. Because we defined all of these elements as data frames within the script, they're now all available for us to dig into and look at if we wanted to. I'm just going to use data set for now because that contains everything that we need. But this is just to show, since we created these different pandas data frames, all the different pandas data frames that we define within a Python script and we execute it, we can have each of those elements available for us to either reference or navigate to within the Power Query editor. And then, so once I navigate to the data set, it's going to look exactly like how it was, just with an additional column of a predicted class. And then we can use this comparison from a prediction to our actual classes within this data set to see how we get it. We're not really evaluating the model, but we're getting a sense of how accurate the model is. just by comparing the predictions to the actual results. If we did want to do a more formal model evaluation, we could definitely do that, but we're not going to get into that detail in this session today. But once this loads right now, perfect, we can see that we transform some of the data types automatically. Maybe I need to disable that. It might help make it run a little bit quicker. But really similar to behavior to other data sources, when we navigate down to other data sources in Power Query, works exactly the same.
Joseph, is it actually querying the IRIS database right now? Is that what's taking this time?
Yeah, exactly. I think, yeah, usually when we're pulling in external data, it's not usually quite this slow. Maybe I get to blame my friend Microsoft Teams for that.
That would be my guess. I was just going to say that.
Yeah, but if you're just referencing something sort of locally in the last step, usually it's pretty quick. Yeah. Here we go. Yeah, so we have our data set. We've changed the data type, and now we can compare this target name column to our predicted target column. Let's just delete this change type step. We don't need it. And if I scroll down, I mean, we could make a custom column to compare these values with each other. But if I see, like, at row 84, the target name does not equal the predicted target. And if I scroll down a little bit further to row, where is it? Row 120 here, we see the same thing. So, you know, our model isn't 100% accurate. We do have some differences between our predictions and our observed values, but you know, the performance is actually so good. You know, we may have overfitted our model, but yeah, like I say, model evaluation, we won't get into too much detail, but we can do just a quick sort of glance to see how our model is performing. But now that I've run that, I can close and load that query, and we can actually load it into our Power BI report. And then we can use the second page of our Power BI report to visualize the results of our model. So if I go to the, oh, it's not letting me. Once these two have loaded, then I can navigate to that second page. I'm just going to do something really similar as we did from this initial Python integration part. I can create two standard visuals. Oh, still working on it. I can create two standard Power BI visuals using the classification data frame, and then we can build a custom Python visual to visualize our model so we can understand how it works and generate these predictions in a little bit more detail. So if I look here, here we go. From classification, let's skip the standard Power BI visuals for now. Let's just get into the good stuff. Let's create a classification tree visual for Python. So as ever, I need to drag in all the fields that I need. So I'm going to bring in target, which is what we're trying to predict, as well as the 4 features that we used to train the model. Make sure that we're not summarizing, which we're not, so that's good. And I'm just going to copy paste some code in here. So I'm importing libraries. I'm defining what our target variable and our features are. I'm defining what their names are here as well. And then I'm creating a tree plot, and then I'm displaying the plot. And if I hit run, here we can see the results of this. And if I zoom in, we can get a little bit of a closer look into the actual tree visual that we can use to interpret the model more. So how we can interpret these decision trees is we always start at the top and work our way down. When we get to the bottom, when we get to the bottom, that's like the end of the interpretation of the tree. So we start at the top. We see that we have 149 samples. So right away, that's a little bit worrying to me, because it looks like one of our rows has got dropped. And so I need to make sure that there's probably a duplicate row in there. So if I were to bring in, let's bring in split as an example, and make sure that that's not summarized as well. And then we're refreshing. Okay, it's not split. This is a case where we might need to bring in like an index column, because one of our rows is getting dropped. So regardless, I'll do that after the fact. But we have a question here, and we're saying that when the petal length in centimeters column is less than or equal to 2.45. So we say if the answer to this top question is yes, we move left down the tree. And if the answer is no, then we move right down the tree. And we keep asking these questions of our data. So this time it's petal width in centimeters. Is that less than or equal to 1.75? If the answer is yes, we move left down the tree. If the answer is no, we move right down the tree. And we get a sense of how this is splitting our data. So at the beginning, we have 50, 50, 50 for each of the three classes. Just by this one question of a certain cutoff point within petal length, we've actually binned 50 of a single class into a leaf node of our tree. And we can see the dominant class of this leaf node. So not only do we get to see what columns or features of our data frame are important to classifying our target, but we can actually see at what point, like what's the cutoff point within that column that can help us classify our target variable. And we do the same thing as we work down the tree. And we could add some additional parameters if we wanted to prune the tree and make sure we're not getting too many different levels to our tree. We want to make sure our model's not overfitting. But this is a great way that we can build in this visual, get a better understanding of this classification model. And this could become part of just a standard Power BI report where we could visualize the output for our model as well. So with that was the last part of bringing in a machine learning classification model into Power BI. Back into the slides. That was the presentation for today. We went about 20-25 minutes over what I imagined. So if anyone's still on the call, thank you for staying with me. I do really appreciate your time. All the example files, the scripts and everything are going to be up on my website. The link will be in the Meetup group by tomorrow morning for sure. And if you have any questions, I know we'll do a bit of a Q&A now. But if you do need to hop off, please do feel free to reach out on Twitter or LinkedIn. And at this point, yeah, just thank you everyone for coming, and we can get started with the Q&A.
Yeah, and just for reference for everybody that is going to drop quickly here, I will be producing this and uploading it within the next 24 to 48 hours, and we'll again publish that in the Meetup group chat once it's available, so you'll know. We'll give you the link and let you know when it's available, so you know where to find it. So, so now I've kind of lost track on the question on the Q&A piece here, because there was some chatter going back and forth again. So. We've got one question here about recommended resources for learning the language.
So the company I work for, Corporate Finance Institute, our business intelligence and data analysis program has a few different Python classes. So I would definitely recommend checking that out. I can add that link to the page as well. I mean, I think we do a great job kind of building up. I'm actually in the midst of redeveloping our Python fundamentals class, and we have some further case studies as well of things like Monte Carlo simulation, doing classification modeling, regression modeling, and some further case studies as well. I think further to that, I mean, I'm not. Yeah, I'm not really sure, to be honest. I think there's tons of great resources out there. There's tons of great, like, even just like in browser based programming academies to sort of get you up to speed. Python's obviously a really flexible language that can do much more just than data science and data analysis. You know, it's super popular. So there's lots of great resources. But yeah, like I think our own courses is what I would recommend, and I'll make sure to have a link to that as part of the presentation as well.
Yeah, that's Corporate Finance Institute, correct, Joseph?
Yeah, that's right.
So, yeah, which is where Joseph is working these days, and in teaching courses.
Yeah.
And developing courses on his own, which is awesome. So, all right, other questions? Is there anything else that we've missed on this? Because as I say, there was a lot of chatter back and forth, and there was a lot of support from the community sort of answering the questions back and forth, which I really appreciate, because as I say, a lot of these terms were quite new to me. So, but I just want to make sure that we haven't missed anything here before we sign off for the day. So,
sure,
and I don't.
Sure. Yeah, I mean, I think one part I didn't touch on in some of the questions about some of the different integrated development environments that you can use. Where that really comes into play is when we're using Python visuals specifically. This sort of arrow icon here. Am I still sharing my screen? I think I am.
Yep, you are.
Perfect. This arrow icon here. Once we've defined the information for the visual, like all the columns that we want, and it creates a data set, by clicking this arrow, that takes the definition, or that takes that sort of like a cached version of that data set, brings that into our development environment, and then instead of sort of copy pasting code back and forth and like defining the data set in one, then defining it in Power BI and running it, we can just define it within a Python visual in Power BI that'll take us into our IDE where we can code and play around, and then we can copy and paste that code back into the visual here. The reason I didn't look at this into too much detail today is we're still having to copy paste that code back and forth, and that integration isn't available in the Power Query editor as far as I know. So for the most part, I think you're still going to be copy pasting back and forth anyway. So I didn't get into sort of the different IDEs available to us. But I will say, if that is something that you're interested in, the configuration is in the options and settings. Where is it? In Python settings, setting the detected Python IDE here. And I know as well that as an external tool, just like how we can add like Tabular Editor and DAX Studio, we can add Jupyter Notebooks as an external tool as well. So I've not played around with that too much, but that's another way that we can integrate. So that might expand the scope of that integration. But yeah, for sort of going through the different examples today, it didn't make much sense for me to sort of get into the IDEs where we're still having to copy paste back and forth a lot anyway.
Cool. All right. I know Sue still has questions. I don't know, Sue. Are you able to unmute to just ask, or did you want to type like crazy? What's your preference? Okay, fire away. Do I have to unmute you? I think. Let me just see here. I do not have the ability to unmute you, unfortunately. It's not letting me do so. I'm not. Oh, there we go.
Hello.
Hey.
Oh,
yeah, we hear you.
Hi, Joseph. That's a great session. Thanks so much. I do have a question though. So, why we not in the Jupyter Notebook export those data sets as Excel file, then you import in your Power BI? Would that make the copy paste the coding quicker, like you far fetch the data?
Yeah, that's absolutely valid as well. Yeah, like we could for sure just define something, like define a data set, save it as like an Excel or CSV or some sort of other data store, and then connect to that in Power BI. Absolutely that we could do that as well.
So the reason we want to bring in the visual, I mean, you use Seaborn or use Matplotlib, so is that I want to, when the data refreshed, I wanted the Power BI dashboard also get refreshed. That's why we want to paste and those codes here, right, to get the visuals.
Yeah, exactly. I mean, so as the data set refreshes in Power BI, the Python visual, just like any other visual, will like the data will be refreshed for that as well. And also I didn't have time to demo it, but if I do it really quickly here, let's just do a basic bar chart. So let's just do a count of split by sepal length. Yeah. So if I click on and sort of narrow our data set down, just like we do like in standard visuals in Power BI, this cross filters this classification tree as well to something like this. So it sort of goes back, reruns the model, visualizes the results for when just this, like, 10 of, instead of training on 150, it just looks at 10 and then displays the results like that. So yeah, we have sort of that live connection going on.
I see. And also, when you use the Power Query to do random, you assign, okay, this is, I go to get this category. This is my testing data set. This is my predictive data set. So my question is, when you assign those categories, do you compromise the random? Because when you're doing that in Jupyter Notebook, it definitely that's a random data set, right? You pick it from your sample data. But when you assign those sequence, you can see the pattern. So where you compromise the random a little bit.
You absolutely are. I mean, I think the reason I did that in the session was well, I guess sort of twofold. Number one, just to show that you can do the same sort of manipulation in Python or Power Query. Like, it's possible to do the same thing in both. And also because the data set was small, we could see visually that, like we were splitting things equally. Okay, it wasn't totally random. It was by the sort. We were relying on the sort order of the data frame as it came in. But it would still probably satisfy that, we could move ahead. But I think you're right. Like if this was an actual model we wanted to rely on in production, we would need, we would do a lot more sort of preparation and training of our model before launching it. We kind of went through this example quite quickly, start to finish.
This is a really great session. Thanks so much for sharing with us.
You're welcome. Thanks so much for your questions and yeah, no, happy you enjoyed it.
Awesome. I don't see any other questions that have come into the queue, Joseph. So I think for now, what we'll do is I'm going to stop the recording and we'll shut it down. But once again, man, I do want to say a big thanks number one, thanks for everything you do for this group, because you're always doing the what's new in Power BI, and usually I always forget to thank you at the end of the evening. So I'm trying to correct some of that. But also thanks for a fantastic presentation. Really appreciate it. It's definitely been lively in the chat, and yeah, it looks like it's very well appreciated. So thanks, bud. I totally appreciate it. Actually, I've got something that says Anthony's got a question. I think Anthony's question was answered on the understanding. It was because it was related to the copy paste, and I think that that got dealt with just before. But if I'm incorrect on that, Anthony, let me know.
No, that's correct. I had an additional question.
Oh, okay, fire away then.
Hi, Ken and Joseph. Nice and like great presentation. Thank you. So let's set aside all this machine learning stuff and say you have the data, you have your model in Power BI, and you just want to build a visual that is not available in standard visuals. So you have to bring that data into your Jupyter and then test it there before you copy the code over. So
yeah, I mean you don't have to go to an external notebook like Jupyter Notebook or whatever your environment is. You don't have to code there and paste it in. Like you can just, if you're building just a custom Python visual, you can just code in here for sure. You like if it's not 100% right, you're going to get an error message and it's going to say why it's not rendering. But you can just code within Power BI if you want to. It's just not the best experience.
Okay. Okay, makes sense. I was just thinking that if you were trying you're doing your trial and error in Jupyter,
yeah,
you have to bring data there first.
Exactly.
If you do so, because you brought your data there, then why playing in Power Query? You can just that piece of the code you can paste in Power Query as a data ingestion step, right?
Yeah, I mean, I think there's sort of two. I think there's kind of two different aspects to that. I think like first of all, if the reason you're using a Python visual is because you like it's not available just kind of as a standard Power BI visual. I mean, you can't really bring that code into the Power Query editor. Like you have to do it in like as the visual. And one thing I didn't cover as part of the integration, and maybe I'll add it for the next time I do this presentation, is you can like there is a way where you're getting like when you define what your data set is specifically for the visual, you can, if you've set up that connection to your IDE, you can render like kind of a cached version of that data set in your IDE to then play around with and then bring that code in. So like you're taking this value, this like data set that's created for you as part of the Python visual. Like, I've dropped in total volume, adjusted close. It's made a pandas data frame for us of these two automatically. It's dropped duplicates. If I were to hit this button and go into like Anaconda or whatever, or like a Jupyter Notebook or whatever, we would have that data set available for us to start sort of playing around trying to build our visual. We don't need to go and recreate the whole data set in Jupyter Notebooks, because you're right. If we had to rebuild the whole thing, then it's kind of like, why are you doing it in two places? Yeah.
Okay. Yeah, thank you. That's helpful.
Yeah, you're welcome.
All right. I think that's it for the questions now. So this time I really am going to shut off the recording and shut her down for the evening. I think here.